Hello, welcome to lesson 4, conservation of momentum in 2D, and I have a question about number 49. So at number 49, I'm going to give myself, I see directions here, so I'm going to give myself a grid, northeast, and let's see what we got going on. 3,000 kilogram car traveling 20 meters per second north, so 3,000 kgs at 20 meters per second, collides with a 5,000 kilogram truck moving east, so 5,000 kgs at, I don't know, it's not given. They become entangled, their bumpers, and they remain joined after the collision. Calculate the initial speed of the truck if both vehicles after collision go east 30 degrees north. So I'm going to assume here we're dealing with momentum, so we're going to do a momentum equation here so that we know that the momentum of car plus momentum of truck has to be conserved. So momentum of, we'll go final. That'll be my equation. So doing the stacked addition for the car, it's heading straight north, so there's no I component, plus 20 times 3,000J. Add the momentum of the truck. It's heading east, so I don't know the velocity, so we're going to use the variable v times 5,000I plus 0J. That's going to give me my final momentum. So I'm going to have momentum in the x, I plus momentum in the y, j. So you can set this up a couple different ways. This is how I'm going to approach it. So I'm going to look at my columns now, and I look at my x component here to start, and I see that I've got 1, 2 variables, so not a good column to start with. So I'm going to leave that one for now. And let's take a look at the y column. So in the y column, my only unknown is momentum y. So I can find the momentum in the y direction. So if we look at our y component, momentum in the y equals 20 times 3,000. I'll put plus 0 in for emphasis because I'm adding up that column, but not really necessary. So we know the momentum in the y component is 60,000 kilograms meters per second. So there's my y component. So I know py. Now, when I look at the question, I know that the final, after the vehicles collide, they're heading east 30 degrees north, so they're heading in that direction. That's the final momentum. Well, I can go to my trigonometry because I know that to find the angle, I need to take the value of the y component over the value of the x component. So I'm just going back to vectors. And I know the angle is given. It's 30 degrees. So tan 30 equals 60,000 over the momentum in the x. So I can solve for or isolate momentum in the x direction over tan 30. And if you plug that into your calculator, making sure you're in degrees, 60,000 divided by tan 30. So I get 103,923 kilogram meters per second. All right, so now going back to the original stacked addition, I now know that value. So there's only one unknown left. So now I can look at the x component. It's the final one, the value that I wanted to find. So x component, I know that the momentum in the x equals v times 5,000, and I'll put the plus 0 in for emphasis. So I've calculated px, it's 103,923, or rho x, depending on how strong your Greek is. And through division, we find out that our velocity here, divided by the 5,000, is 20.8 meters per second, and it was heading in the east direction. So I know the answer in the worksheet says 35. I believe they're incorrect. Unless someone sees a flaw in my logic here, I'm saying that the answer should be 21. All right, so therefore the truck was traveling at 21 meters per second east. All right. If you have any questions with any of the steps there or want something further explained, let me know, and I will do my best to answer those questions. Good luck.